Let me share my screen. Are you guys able to see my screen?
Yep.
Does it look all right?
Yeah.
All right, awesome. Yeah, so I appreciate everyone coming out. I know that I am remote, so I apologize if people were expecting me to be there in person this time. Maybe next time. But my name is Nick Raboy. I'm actually a developer advocate at Couchbase. But I won't really be talking about Couchbase today. I'm going to be talking more about NativeScript and Angular 2 because those are what I work on as a hobby. So I'm very passionate about this stuff, particularly Angular 2 and how it can be used in a NativeScript native mobile application. So I am in California. Right now I'm in the Bay Area, not San Francisco. I do work out of San Francisco, though. I don't live there. Generally, people who live there are quite rich. That's not me. What I'm going to talk about today is we're going to really go over some of the differences between native applications in the sense of what Apple and Google has intended them to be, kind of where NativeScript comes and fills the gap, and then how you can bring that to web and then back to mobile or in either direction. When it comes to developing native applications in the sense that Google and Apple have intended, so of course if you're developing Android, you're going to be using the Android SDK with Java. Or if you're developing for iOS, that's Objective-C or Swift, or maybe both. Before I started developing hybrid applications or cross-platform native applications, I was actually an Android developer. I did all of my development with Java. I did this for quite a few years and never touched iOS at all. Kind of didn't really own a Mac at that point. But the thing about developing this way, your applications, is that of course there's more language requirements. So as a solo developer, it doesn't make a whole lot of sense to learn all of these technologies. It's a lot to remember, a lot to keep track of. Or if you're part of a company, it's going to require more developers. It's going to get costly. It may not be the best strategy. And then that's of course where NativeScript comes in. So NativeScript kind of consolidates that code base. Instead of working with Java and Objective-C and Swift, you're now looking at working with XML markup, some CSS, some JavaScript. So very similar or spot on to web technologies, but not quite something that you could swap over to be a website in the end, because with vanilla NativeScript, not Angular, you're actually working with MVVM, which is the model view model. But you do get to code in this with a single set of code, and that single set of code does get deployed for iOS, Android. I think Windows Phone might even be coming. But that's incredibly convenient because those are, of course, fewer development technologies that you have to know, and fewer developer skills required in your team. So if we're looking at web, web is similar to what you saw on the past slide. You're not working with XML, of course. You're working with HTML, which is similar to XML. Some might even say it's the same. But you're still working with CSS and JavaScript. But you get the door opened when it comes to different frameworks. So you can use stuff like Angular 2. You can use React.js, jQuery. There's a ton more. And although a lot of these frameworks don't necessarily use the MVVM, I think a few of the frameworks, maybe Ember, might use MVVM. I'm not sure on that one, though. But I'm sure there's at least one that can. But more importantly, web development is easy. So, I mean, anyone can do it. You don't need a degree for it. Your grandma could probably do it. It's pretty easy in comparison to developing mobile applications, whether that be even vanilla NativeScript or, of course, native with Android SDK and Objective-C. When it comes to bridging this gap, so being that web supports Angular 2, which is, if you haven't played around with it, and this is your first time being exposed to it tonight, it's a very sharp framework. And the best part is that it actually works perfectly with NativeScript 2, which came out earlier this year. So now you're no longer working with a single set of code for both Android and iOS, but now you're able to work with a single set of code for Android, iOS, and the web. So that reduces the amount of skills that you need for all of these different deployment areas. When I say that you don't have any of the disadvantages of hybrid mobile, so if any of you are familiar with Apache Cordova, PhoneGap, Ionic, that kind of stuff, those are hybrid technologies. They work via a web view, so the applications get rendered in this web view. Depending on your device, if you have a slower device, the performance could be a obstacle because not all devices have a very performant web view. So being that NativeScript compiles all of this to native code, you're running at native performance. And then, of course, there's fewer necessary developer skills. So this walkthrough, I'm going to be walking through a lot of code here. If you can't see the code that's on my screen on the next slides, let me know and I'll see about zooming in. We'll go from there. But so we're going to start by looking at a web application. This web application is going to be created with Angular 2, CSS, and HTML. I'm going to show you what this application is, and then we're going to look at the code behind the application. Once we look at that code, we're going to see how easy it is to convert it to a mobile app. So let me exit out of my PowerPoint here and find my web browser. Oops. Let me zoom in here. Can someone tell me if that looks zoomed in enough?
Looks like it's good.
Looks like it's good. All right, perfect. So this is a very basic web application. It has two components or two different routes or screens or pages, views, whatever you want to call them. So this would be the first one where it displays a list of items. Right now I have nothing in that list, but I have the opportunity to add to it. So if I click the plus button, it'll take me to a new route. So it'll be small, I assume, but it took me to this create page, this create component, where I can now enter some details. And when I click save, it'll actually save it to local storage, part of HTML, and then it'll take me backwards in the navigation stack, where it will then list whatever's in local storage. So let me start going over the slides with the code here. Find my PowerPoint. All right. So this web application, to build it, I actually used the Angular CI, which was recently released. It's incredibly convenient to use when developing Angular 2 applications. The requirement to use the CLI is that you need to have Node.js installed because you need the Node package manager. So once you have the CLI installed, you can do ng new and then the application name. And then you can just go in and call ng serve and it'll run it on port 4200. Or you can do ng build and it'll compile all of that JavaScript into more compact and minified files that you can deploy. So first of all, can you guys see this code?
Yes. Yep.
It's visible? All right, hold on, let me get a drink. All right, so this code would be the list component. So this goes with the first screen that you saw in that particular web application. So first of all, we're importing some core essential Angular 2 components. We're including the components so that way we can pair it with an HTML file. We're including the router so that way we can do navigation. And then location will be similar to the router, but I'll explain that in a second. So inside of the component block, we're defining some things like the module ID, the selector, but more importantly here, we're defining the template URL and the style URLs. So by saying this template URL, we're saying that the list.component.html file will be paired with this particular TypeScript file. They'll run in combination. We're also saying that we want to have local style sheets. So this list.component.css will be a local style to this HTML file. It will not be global to our application, just this particular page. But we could add other styles if we want. Or we can go up in our application directory and we can make a global style if we really wanted to. Next up, we create a class. This particular class is called list component. It has a public variable called person list, which is an array of objects. We're making it public because we want to be able to access it from the front end, from the UI. Does anyone here have Angular 1 knowledge? Yeah, some. So by saying public, it's similar to saying scope. So it works similarly. Anything that's public can be accessed from the UI. We have a constructor. This constructor gets launched as soon as the page loads. And then we have a public create method, which will be responsible for navigating. So let's take a look at these methods as part of the list component class. The first being the constructor. So what we're doing here is, first of all, we want to populate that person list, and we're populating it from local storage. So what we want to do, local storage is a key value storage. We're storing everything in this key called people. What we're actually storing is a serialized JSON object. So we're serializing it into a string. So what we're doing is we're checking to make sure that something exists at that key. If it does, get it and parse it into a JavaScript object. If it doesn't, we still need to initialize that array. We just need to initialize it as blank, otherwise we may get errors, so we're initializing it as an empty array. This brings us to the subscribe. So this .l.subscribed. L is for location. And what we're doing here is we're subscribing to changes in the navigation stack. So when we navigate away from the list component and we navigate back, the constructor doesn't get fired again. It's already been fired. So what we need to do is we need to subscribe to these events when we navigate backwards in the stack. So we're subscribing, and when the notification happens, what we're going to do is we're going to requery this key value storage and populate the person list, which will then be rendered to the UI. Finally, we have this very small create method, which will allow us to navigate to the create component. So let's look at the HTML that powers this TypeScript. It's very basic Bootstrap. I'm going to take a wild guess and say most people have used Bootstrap. If not, you maybe used Foundation. Very similar. But ignoring all of the Bootstrap, let's take a look at the link with the glyph icon plus. So it actually has a click event. So when we click on it, it's going to call that public create method. And if you're familiar with Angular 1, you'll probably remember it being ng-click. It works the same, just has a slightly different name. Then if we drop down into our list, our unordered list, we have a ng4. So this is similar to ng-repeat if you're coming from Angular 1. So we have our public person list, and we want to iterate through it. Each element of that list is going to be person. And being that each element of that array is an object, we can then print out each of the items in it. So first name and last name, which I may have called differently in the previous page. It might be F name, last name. I forgot what I put on the previous slide. But we're able to render this with the double curly brackets. And feel free to stop me if anyone has questions, because I can hear you guys pretty well. So feel free. Let me get some water. So here's our second component. This is the only other component with visuals that we have. This time we're not importing the router because we're not routing further in the application. The only option we have from here is to navigate backwards. This time our template URL is paired with the create component.html, and of course we have a CSS file that goes with it. In this particular scenario, we have a public person list again. In this case, I probably could leave it out because we may not need to use it, but it's public, it's there. We also have a public F name and public L name. So these actually get bound to a form that appears on the UI, and you'll see that in a second. We also have the constructor, and we also have the save function here. So the code that goes into those, of course, is we're loading our person list again. So we're getting it from local storage. Otherwise, we're initializing it. We're also initializing the F name and last L name to blank. because we want it to be blank in the form when the page loads. For the save, what we're doing is as long as fname and lname have a value in it, then we're pushing a new item to this person list. It's an object. It has the first name and last name. Then we're serializing it using JSON stringify, and we're saving it back into the people key. So everything's getting mashed into this people key. When we're done with this, we can call location back, and it will navigate us backwards. So here is the HTML that goes with it. Again, I put the important stuff in bold. So again, there's the click event. So when you click on the floppy disk icon, it'll call this save method, the public save method. But we also have this ng model. So if you're coming from Angular 1 again, you might be familiar with ng-model. Well, it's still here in Angular 2. It just is slightly named differently. This time we're binding this particular input field to the fname public variable, as well as the lname public variable. So that way anything that we type in here we can access via our TypeScript. So now that we have two components, two visual components, we really need to bring those together. We need to link them up, because right now the Angular application, they're out in the nowhere. They're not connected. So now we need to start connecting them. So we have our app component. This is pretty standard when it comes to any Angular 2 application. It sits outside of our other pages. But in this case, we're defining our required components here. But what's important here is the template. So notice how it's router outlet. Any route, any component that we wish to be able to navigate to will be piped into this router outlet. It's kind of like UI view, if you're familiar with the Angular JS UI router. So it's similar to that, where everything gets piped in there. You could have HTML code around the router outlet. Maybe you want to have like a parent theme. You could easily do that. It's up to you. Now that we have a way to kind of bring all of our front end into this router outlet, we need to define those routes. So in the main component, which is pretty standard in any Angular 2 application, we're defining all of this Angular 2 component stuff. We're bringing in list component and create component, which we've already created, but we're creating app routes. So inside of app routes, it's an array of every possible route in our application. The route that does not have a path is the default route. So when the application loads, anything that has an empty path will be loaded first. So in this case, it's the list component, and then we have the create component at the path create. So this is actually using the Angular 2 3.0 router, so the router that just came out. So this is bleeding edge stuff. Previously, it was pretty different before. So this is actually the new way to do it, and I'm hoping the final way to do it, so that way it doesn't change again. It's changed several times since they thought it up, but hopefully this is the final time. Once we have those routes, we can bootstrap the app component and add those routes as well. That was everything it took to build that simple application. It was very clean. There wasn't a whole lot to it, and it wasn't. I would say that it's actually easier to do than Angular 1. Now we're going to take a look at what it takes to convert that into a native Android and iOS app. So it's not going to be a web application. It's not going to be a hybrid application. It's going to be native application. But I'll show you a demo first. Before I do, is there any questions up until now? Nothing? All right. So let me go find my simulator wherever they may be. All right, so let me go ahead and say TNS on Android. Just take a second to run.
Hey Nick, I've got an Angular 2 question.
Yeah, sure. Go for it.
So in both the constructors and in your controller classes, you loaded from local storage. Is there a concept of the root scope for Angular 2?
So something that would be more global to the application.
Right.
Yeah, so you can actually create singletons or shared providers or shared services, and I'll actually show that in one of my later examples. But yeah, that would be the most ideal way to do it, rather than trying to reload it every time. So good catch. So I do have this loaded. It's of course got a different UI than the web application, but I'll just run through it real quick to show you the simplicity. Go ahead and add this item. Click save, and of course it's added. And it's not really styled or anything. I have added no styles to this application. This is exactly what you would get with the raw Android SDK. You can fancy it up however you wish. So let me go ahead and go into my slides again. So first of all, we're no longer at this point using the Angular CLI. We're now using the NativeScript CLI tool. So again, you need to install that with Node.js. Once you have it installed, you can do a TNS create and then the application name. When you include -ng, that lets the CLI tool know that you want to build an Angular 2 application. If you don't include ng, you'll be building a vanilla NativeScript application that uses the MVVM approach. Once you have the application created, you can go ahead and add your two platforms, Android and iOS. If you're not using a Mac, although you might be able to add the iOS platform, you won't be able to build for it. You're going to need to use some kind of build tool for that, or go out and buy a Mac. You'll only need the Android SDK for building for the Android app platform. So I'm going to show some of the differences here. I'm not going to include all of the code again because a lot of it is just duplicate. So in this case, since we're building native applications, there is no concept of local storage for NativeScript. No concept of that whatsoever. But there is what's called application settings, which is also a key value storage. So I am importing that. It's slightly different than HTML5's local storage, but not too different, and not different enough to where it would cause you a lot of heartache to update in your code if you're converting it to mobile. So in this case, I have this is the list component inside my constructor. I can call storage.getString. In this case, I can actually specify a default value if it doesn't exist. I don't have to do that check, which can add extra lines of code. Instead, if it doesn't exist, it'll just return a string. Of course, it's a serialized JSON array. In this case, I am parsing it out into a JSON array that I can use for person list, which is also an array of objects. Again, I'm subscribing to a navigation event, so it's going to be the same line again. What's different here is in the actual UI. So you're not using HTML, you're using XML. So there are some differences. So in this case, we're creating XML, and there's an action bar, which is the header. It has a title, and then of course it has that add button up top. So that's our action item. Instead of click, we're calling them tap events. So when that button's tapped, it's going to call the public create method that's inside of our list component class. Then we're going to drop down into our grid layout, which is our core content, and we have a list view. Instead of doing ng4 to loop through that person list, we're saying, hey, the items that are going to populate this list view is this public person list. And for every item in that array of objects, we're going to call it item. This brings us to label. So we do have text in square brackets. By putting it in square brackets, we're saying that this is a variable that we're working with, not plain text. If we want it to be plain text, we would just drop the square brackets. But in this case, we're saying we want to print out item fname and item last name inside of this label. So if we look at the create component, again, slightly different but not too far off from what we saw in the web example. Again, we're importing the application settings for key value storage. We're initializing person list, fname, lname. We're making sure that it's all good to go. And then inside of our save method, we're checking to make sure that these are not blank. We're pushing them into the list, and then we're serializing it and storing it in our storage and navigating backwards in the stack. So pretty similar. When it comes to the UI component, again, this will be the most different part between your web and mobile app. So again, we have an action bar. This time we do have an extra item in that action bar. We have a navigation button. I'm calling it back, because if you don't include one in your routing forward in the stack, it's the back button is actually going to have the title of the previous template. So I don't really want my navigation button to say NativeScript list. That's very long. It's not very nice. I'm renaming it as back. I'm also adding this action item. Again, it's a tap event. It'll call the save method. And then I'm also binding the two text fields, the form elements, to the public variable. So this is pretty much near identical to what you saw in the web. So the conversion so far has not been too stressful, because everything that we've seen so far, aside from the storage component and the UI, has been the same as what we saw in the web version. This is where things may get a little different, not by much, but this is that app component, similar to what we saw in the web version. We're importing the Angular component. We're also importing a NativeScript component. So previously we were importing router directives from Angular router. This time we're importing NS router directives from NativeScript Angular router. So the naming convention, the NativeScript guys have kept it very close to what Angular is calling them for convenience. It's easier to remember that way. Other slight difference in this is, instead of calling it a router outlet, we're calling it a page router outlet. So just a minor difference in this app component versus the web version. So now we have our main component. So again, there's going to be minor differences here. Instead of importing Bootstrap from Angular application, we're importing NativeScript Bootstrap. We're importing NS provide router instead of provide router. Other than that, we're doing pretty much exactly the same thing that we did on the previous. We're calling NativeScript Bootstrap, we're passing in the app component, and we're linking up the two routes that we defined. So that's all the conversion I had to do to make the two different applications possible. It wasn't difficult. I've made much more complex applications than what I demonstrated, and it's really not too bad to convert between the two. Does anyone have any questions as of right now?
Nope, we're good.
All right, awesome. So as a mobile app, you probably don't want to keep basic stuff, although you could. It depends on your business needs. But instead, we can actually make use of platform APIs and plugins with NativeScript. So say, for example, you want to access native platform APIs in your application. Maybe you want to access the device camera. Maybe you want to access Bluetooth or NFC or any of the other many possible device features. You can absolutely do that with NativeScript with very few lines of code. It's a lot easier to do it with NativeScript than trying to figure out how to do it in Java and then trying to go back and try to figure out how to do it with Objective-C. You also have the power to use whatever Android and iOS SDKs are out there. So these won't necessarily be platform APIs. These will be SDKs that are part of some company's product. Maybe you want to use Couchbase or Socket.io or Firebase, and maybe they don't have a NativeScript plugin. That doesn't matter. You could still use them. So that's a huge convenience that NativeScript offers. So for example, if you wanted to use NoSQL, if you wanted to use Couchbase in your application, maybe you don't want to use SQLite. SQLite is very common in mobile applications. It is an option, but maybe you don't want to. Maybe you want to use a third-party thing. So in this case, let's say you've included the SDK, the Couchbase SDK, in your application, and then you could say new Couchbase and then define what database that you want to use. Then you would create a view. So instead of running SQL queries, this is NoSQL. So you're creating what's called a MapReduce view and adding some logic on what kind of documents to be returned. In this case, we're going to return all people because there's no logic. If we wanted to say all people with last name of such and such, we absolutely could. But that's a little beyond the scope of what I'm after here. When we want to query this view, we can say execute query and then query this people view because that's what we called it. And we could loop through all of the results and do something with each of the rows that was returned. Or maybe we just want to create a document, a NoSQL document. We can actually pass in a JavaScript object. We don't have to worry about parsing it into some kind of SQL query, which can add a lot of extra steps. Or maybe you want to use the Android and iOS camera. So in this case, we would import the camera, and then we would just call camera.takePicture. It'll open up the device camera. You go ahead and take your picture, and it'll return you back to the app with information about the picture. It'll tell you where that picture was stored. It'll give you base64 information, and then you can do what you please with that information. So in these 3 lines, you could do a whole lot. So I do want to show you another example, just kind of food for thought, and you could give you something more complex to play around with on your own. Let me find my terminal again. So I'm going to run 2 different apps here for iOS and Android. They're going to build in a second. This is actually an app. It does use Couchbase, so I lied at the beginning. I said I wasn't going to talk about Couchbase. This is just an example of doing a synchronization. It's just an example of what kind of things you could do with NativeScript with not a whole lot of effort. So as soon as it deploys.
While that's deploying, I got a question.
Yeah, sure.
It seems like a lot of the core component logic might remain the same, but
I lost you. Are you still talking? I don't know if I lost connection or not. Hello?
the view, you're developing a web version of your app and then trying to make it work for your, mobile.
Yeah. I lost half of what you said. It cut out. You want to repeat that?
Sure. It seems like a lot of the component logic stays the same between the 2
Yes.
versions, the web version and the native version. How do you keep if you're treating your web application as your primary application, how do you keep them in sync with your native version of the same thing? Because it seems like the views change a whole lot more than the app component, or the core logic inside, right? Not the HTML or the XML.
Yeah, that's a good point. So the good thing about that is chances are your web application is going to look very different than your mobile application. It's just the way things are done, and that's fine. So that's you kind of just build your web UI, build your mobile UI, and keep them separate. That's fine. They should, in theory, still share the same backend. I mean, how you can do that in kind of a continuous integration type way, it really hasn't affected me much, but I get what you're saying. I don't know if other people who build mobile apps and web apps in the room have dealt with this kind of scenario before. No,
Let's
maybe.
say that your web platform, we have 32-inch monitors, right? And
Yes.
the same UI for that monitor would be a bad choice for this.
Sure. Yeah. So I think the views would change a whole lot.
A lot.
But like the procedure to create, update, get person list, that stuff, that the logic that exists in the component, but not the template.
Right.
Right. It seems like a lot of that would stay pretty consistent between the native version and the web version.
Sure, you can share lots of code that way. And frankly, that's one of the reasons why we chose to use Angular 2 is because it does divorce itself from being dependent on the DOM. And it is basically just a way to structure your code. And so by swapping out the view, you can take wide chunks of your application. I mean, I could make up percentages, but it could be 60, 70% on something that wasn't so view customizable. You just use it.
Yeah.
It's the same.
So to add on that, before NativeScript started supporting Angular 2, I was using NativeScript with the MVVM, and it was a whole lot more difficult to keep the web and the mobile in sync because even though that they were both using JavaScript, it's just a whole different kind of build process of your code. Being Angular, although not perfect in swapping seamlessly between the two, it significantly reduced my effort.
Is there a workflow apart from just running Bootstrap out of a mobile browser that would keep a single repository for a code base, or are you still pretty much always running out of 2 repos?
I don't know. It depends on how you build your scripts. I mean, you could easily make some grunt or gulp scripts that kind of fill in the gaps when you build. I think that's more dependent on your business needs and design than anything. Anyone else care to chime in on that?
I'd say if you use JSPM at all, we have 2 separate websites right now, 2 web apps that share a same common code UI base, and we use JSPM for that. It works really well that you can update ours, the other one does too. But even if one word, is different, one dependency is different per controller, that still doesn't mean, it means every file is still going to be different. So I don't know if there is an easy way, because even if one word is different, it's got to have to be a different file, That worries me just a little bit, that it isn't going to be a seamless, build something right away.
Until I got a Docker on a file.
Yeah.
I didn't catch that last comment.
It's pretty fair to say that the Angular 2 full release is not out yet. They're not finished. And so the NativeScript 2 release can't really be out yet either. Like we say, we'll be done 2 weeks after Google's done, and they have no revenue pressure, so they're not in a real big hurry. But once they stabilize, I think our goal would be to reduce the amount of differences where it makes sense between normal Angular 2 code and Angular 2 code you'd use in NativeScript for the reason you're mentioning. One of our main values is build your iOS and Android app out of the same code base. So you're not having 2 separate teams working in 2 very different languages, chasing very different bugs and very different deploy dates. I don't know if you heard of this app called Pokemon Go. Anyway, so there's this app, but they were able to release their iOS and Android version on the same day. Now, that contributed greatly to their success. Imagine if it was just Android people walking around. It wouldn't have gotten nearly the traction that it did. And so I think our, kind of bringing this back around to the original question, as it makes sense, we don't want to force it, but as it makes sense, we want to create the same paradigm across the web and the mobile code bases, because that's a strength. We want to give that to you, but stay tuned. There's more to come.
Is there any idea of deployment on a mobile device, almost like a Docker engine or something like that?
Yeah, are you talking about showing your code on a mobile device? It's deploying it as far as looking at it for testing purposes, or
just as you run on a Linux server, you run it on your phone, right? So that's the installation process.
Well, when Nick is building, it's basically, I can't tell Nick if you're building iOS, you're building for Android. It's basically
I build for both.
A file and then pushing that to the device. And that's a fake device, but you could have it pushed to your real device if you wanted to. Is that what you're asking about? Okay.
So I actually have iOS and Android open. I don't know if you're familiar with the software that Apple purchased recently called TestFlight. You can actually deploy, there is TestFlight APIs, you can deploy there. Not with NativeScript entirely, you'll still have to do some other stuff. But if you're looking to have more people test before you release it to the App Store, That's an option for iOS. Android has something similar. I don't think it's as great as the test flight option, but there are ways to get around this kind of thing.
It sounds to me like what Ionic has, this thing called Ionic, I think it's Ionic View. You can upload your app to the cloud and download it in the context of their empty app and just run it as though it were installed with never is.
Yeah, we have a product called the Telerik Platform that does something like that. If that's of interest to you, catch me later and I'll send you links to it. You
Yeah.
can build iOS apps without an iOS device, but
The thing about the Ionic View though is that it's really just a shell to a web application. So it has problems when it comes to native components. Whereas with NativeScript, you're building native applications. These cannot be emulated in a web browser. So it's a different kind of concept. I mean, you have to pick and choose what's valuable to you. Are you valuing this easy way to prototype and have people test, or are you valuing performance and native look and feel?
Sure.
I mean, either of them are fine. So I do have this application open for Android and iOS. So let's say I want to create a new item here. Oops, that's all right. I'll just leave it as a typo. We'll fix it later. So I saved it. It's synchronized to my Android simulator pretty instantly. I'll go ahead and add another one here. Oops. And then it's synchronized to my iOS simulator. I don't have an edit feature in this particular application, but if I go to the storage solution that this data is being synchronized to, and I go to this database here, I do have both of these records here. So if I go find the one with the error, and go ahead and save it there, and navigate back into my simulators, it's already been adjusted. So this is Couchbase. Some of the features that Couchbase has it's a NoSQL database. If this particular meetup group wants to have me back to talk about it more, I'd love to. But for my goal, what I'm after right here is just to show you that you can do some pretty neat stuff with NativeScript, and it's pretty fast at what you do. So that's all I have actually. So it was just meant to be an overview to kind of get you started and give you a taste on both the latest Angular 2 and how to use it in NativeScript. But if you have questions for me personally, beyond this particular meetup, I do have time to stick around, no problem. You can find me on Twitter. I also write a lot of tutorials on my blog, or you can visit the NativeScript documentation. There are a lot of good examples and tutorials there as well.
great. Thanks, Nick.
Thanks, Nick.
Yeah, definitely.
So while we have Nick, what questions do you have?
I have one question. I've never looked into Couchbase at all. It sounds identical to Firebase. What's the biggest difference between the two?
Yeah, so on a quick level, so Couchbase is a software where Firebase is a backend as a service. So you can install Couchbase anywhere. It could be AWS, it could be Docker, it could be whatever you want. If you want to move it to a different location, you absolutely could. Whereas Firebase, it's really closed source. You don't get to see a whole lot that's going on. If Firebase should happen to close down, I mean, it is likely not to close down, but you never know because Facebook shut down Parse and these other services shut down theirs as well. It could happen. It could be a hassle. I don't know. It's really depends on what you're after. So are you after owning your own data, or are you after paying somebody else to manage your data?
Okay. Is the interaction between the two almost the same then?
On how you use them?
Yeah.
It's similar. It's very similar. Yeah, it's similar. That's as far as it goes, pretty much.
So another question, how does this compare? I'm reading comparisons. I don't have a lot of experience, but to React Native, and can you differentiate? It seems like some of the intention, and I know there's a philosophy that a native app shouldn't come from a web app, but, obviously people would like to preserve their code base as much as possible. It seems like React Native is more tailored to that. Can you differentiate, and can you tell us advantages of the NativeScript?
So although I haven't personally spent too much time with React Native, so you have stuff like NativeScript, React Native, Xamarin. These are three frameworks that actually compile your code to native code. So of course Xamarin uses C#, React Native uses React.js, and then NativeScript uses Angular. All three of them are good. It really depends on your development preference. As far as how the things tick underneath, that is out of my comfort on explaining, since I don't have enough working knowledge between the three. Maybe Dan does, or somebody else over there has personal experience with React Native.
Anyone? No?
Some of your questions that you got earlier seem like they tied into React Native, because maintaining your code base while still exploring native capabilities of the phone seems like something that I'm just reading from a website tells me it can do. That seems really valuable. And I don't know whether there's a good lingua franca from the web page to the mobile app. I don't have enough experience with that. I can see there being a lot of UI difficulties in people converting. But obviously preserving the code base seems like
Well, you got to ask what you're preserving. So a phone, for example, has a web view, but that's like eating a sandwich with a wrapping stick on it, because you can't get down to the native GPU. You can't get down to the native capabilities of the device very easily, because what the web view is designed to do is show you a web page. And if you Google things like, web view click delay, or web view performance issues, or web view list view issues, there's if you're building a simple app that doesn't have a lot of data, doesn't have a lot of interaction, then using a web view is absolutely fine. But the minute you need to put 100,000 items in the list, or show 60 frames per second animation, or something like that, it's not going to work. It's not what it's designed to do. In terms of React Native, this is a philosophical thing. You could turn it into a holy war if you wanted to. Many people do. But it comes down to, do you like React or not? And if you like React, you'll like React Native. And if you don't like React, you won't like React Native. When I see React Native code, I see a lot of native code in React Native code. And frankly, I got into NativeScript because I didn't want to write native code. Like Nick said it very well. You have Objective-C, you have Swift, you have Java. Those are the languages you need to be familiar with in order to make native applications on only two sets of devices, iOS and Android. I can't remember where my car keys are half the time. Have you seen Objective-C? It's horrible. It's like a language was designed by somebody who sold the little square bracket keys for keyboards. I don't get it. I could learn it, but why? Why would I want to do that? So, beat me up after class if you want. I like NativeScript because basically what it does is it tries to let you use what you know and what you like to use to build good cross-platform native applications. And that's the philosophy I got behind. I loved it so much, I quit writing code and became an evil marketing guy. So that should carry some weight, folks. It really should. I had 16 years of this typing code stuff. So that's my take on it. If anyone here wants to defend React, I'm not attacking it, but wants to defend it,
I agree with Dan. There's going to be two people. There's going to be the people who like Angular. There's going to be the people that like React. I think both of them work pretty damn well. It's just a preference.
I got a quick question. I was under the impression that rather than compiling the JavaScript to native code, that a NativeScript actually hosts Google V8 and executes it, but Google V8 is so fast it doesn't matter. Is that correct?
Right. Yeah. So it compiles the XML to native code. That's kind of where it matters the most.
Yeah.
So that's one of the sneaky things about NativeScript is if there's a feature that comes out in Android 7, NativeScript supports it already, even though the feature doesn't exist. And so with other types of cross-platform tools, you have to wait until there's a certain amount of bridging or binding code written to give you access to these capabilities. With NativeScript, as soon as the capability is on the device, whether it's in an alpha, beta state, whatever, we have access to it. You have access to it directly from JavaScript or TypeScript or Angular. And that's pretty powerful because you're not beholden to us releasing an update for you to get your job done. Just use it. And it's free and open source, guys. We're no tricks.
Yeah, I mean, NativeScript actually has I don't know if you use Slack or not, but the Slack channel is top notch. So everyone is very positive in that Slack channel, and they're very supportive of developers at any level. So if you do decide that you want to give it a shot, and you do find yourself stumped, just go ahead and join the Slack channel, and I'm pretty confident they're going to be able to help you out in there.
So looking at the web and NativeScript TypeScript files, they're separate files currently. Is there any way to kind of have them in a shared repository instead of having to copy-paste methods as you update?
So TypeScript is actually a superset to JavaScript, and it actually gets compiled into JavaScript during the compilation process. So you're going to be left with JavaScript files in the end.
No, so but in what you showed, you actually had two different TypeScript files, even though the logic was largely the same, right? You had local storage on the web TypeScript, and then you had native storage on the NativeScript.
Yeah.
Right? So my question is more, how can I have a single file, even if it's, if inside native, call storage, if else, call local storage?
Yeah, so you can actually, so let me show you something. It won't be exactly what you're talking about, but it might put you on the right path. So let me open up some code here.
That might be where you can use a pickle and you run time and swap things out.
Like a storage service and inject it.
Right.
Yeah, so
Like that.
so let me zoom in. So right here, this is that singleton that I was talking about when the question came up. So this would be the Couchbase singleton. It is shared across all of the components. So what you can actually do is you could add your wrapper logic inside of something like this, where it will make that determination for you. So you have access to figure out, hey, am I running on the web, or am I running on mobile? So you can just add some logic in there, and then maybe if that yields null or something, you skip over it and do the web version, or vice versa. So you can definitely add this. It'll add a little more to your code weight, but it's an option. Does that sort of answer your question?
Yeah, so whenever you did your NativeScript projects, did you have web versions as well?
As of right now, I don't, because I haven't done any web for quite some time. I don't know. I'm not much of a designer, so I get a little turned off when I try to make websites because they kind of look crappy. But
Two.
yeah, so you could. I mean, I don't think it'd be too stressful to do that.
Okay.
Any other questions?
What's the final release date for Angular 2? Tell us tonight.
It won't matter because 201 is going to include all the things I'm looking for.
So the best guess is there will be an RC5 in the next 2 weeks, 2-3 weeks, and they'll release 2.0 in September at Angular Connect in late September. That's the best guess. How do I know this? I don't. Would I bet my kids' lives? Maybe. Depends on the day, but probably not. So don't take that to Vegas or anything.
Not your favorite one.
One of them likes to get up at 2 a.m. and I don't like that. Tech support is closed at those hours. Hey Nick, thanks a lot for doing this, man. I appreciate you giving the meetup. Everyone seemed to really enjoy it. We have your information. I'll pass it around if anyone wants to follow up or catch you on Twitter. And certainly thanks again.
Yeah, for sure. If the recording comes out well, I'll upload it. Thanks, everyone. Have a good evening.
Yes, sir.